So we have a blue object and a purple object. Appraisal problem 5. So we have a blue object and a purple object. Let's get these drawn. So the blue object is 4 times as massive as the purple object. And the purple object is traveling twice as fast as the blue object. Let's put in some numbers. Let's say the purple object is 1 kilogram. Then the blue object will be 4 kilograms. And if the purple object is moving at 2 meters per second, the blue object will be moving at 1 meter per second. And when we compare these momenta, momentum of the purple object is going to be 2 kilogram meters per second, and the momentum of the blue object will be 4 kilogram meters over seconds. So when we want the ratio, that means PA over PB will be 1 over 2. Number 2. A space probe is moving along its orbit when it encounters a very, very large asteroid coming straight at it. The two collide. Which one experiences a larger force on impact? Neither. Because Newton's third law says they exert an equal and opposite force on each other. So neither by Newton's third law. Which one has a longer time of impact? Well, they're hitting each other. So what that means is that they completely and totally balance the times. I hit you, you hit me. Our time in contact is the same. It's the same collision. Now, it turns out what this means is that F on the asteroid from the probe equals F from the probe from the asteroid, and they're negative. Now let's calculate the impulse. Well, that's force on the asteroid from the probe times time, and that's going to equal force from the probe because the asteroid hits it times time. So this is what the asteroid feels. This is what the probe feels. So they have totally equal impulses. So if they have equal impulses, since impulse is the change in momentum, they're going to have equal changes in momentum. So they're going to be the same because we have equal impulse and therefore equal change in momentum. This stands for change in momentum. Okay. And for part D, which object sustains more damage? The small probe. The equal force on a smaller object damages it. So let me say that better. The equal force on a smaller object damages it more. Finally, 2 examples how an object can be minimized during stopping. So let's use the impulse momentum formula. Ft equals mv final minus mv initial. So here's one example. Okay, car hits foam, or actually no, car brakes instead of hitting a wall. This is because the brakes gives smaller force over longer time. Now, a second example, just to go here. A second example would be the egg drop lab. The paper cushions the egg, meaning it gives more time to stop, but less force. And that's it for Appraisal 5.